All right, today we're going to be factoring quadratics, trinomials, and binomials, so 3 terms and 2 terms. And the 2 terms are usually kind of special, so let's get into that. So what I like to do is view these just like we have been doing when we have 3 terms. So if we look at this first problem here, we have x squared, and it's missing its term with just the x. So we can say plus 0x minus 9. Now if we do this the way that we've been doing this in class, looking at this, a is 1 because there's a 1 in front of your x squared, b is 0, and c is negative 9. If we set up our chart, what multiplies to give you a times c, which in our case is negative 9, and adds to give you b, which in our case is 0, we can start to figure this out. So 1 and 9 will multiply to give you 9, but they definitely will not add or subtract to give you 0. They either give you 10 or 8, so this won't work. The only other combination you have is 3 and 3. And these will add and subtract to give you a 0. You just need to have one of these 3's be a negative. So now we can take these two numbers and we can split our middle into those. So this goes away. We have x squared using these two numbers here, minus 3x plus 3x minus this 9 on the outside. Grouping these two together, take an x out, and x minus 3 is left over. Group these two together, take a 3 out, and x minus 3 is left over. So going off of the last lesson we learned, you look at these two terms here, and the big GCF they have in common is an x minus 3. So if you factor this out of here and then read this left to right, x plus 3 is what you'd have left over. Remember, if I'm going too fast, you have control of the video. You can pause it, you can go back, and you can watch more. So keep that in mind. Looking at this next one, we're going to do it the same way. So if you notice, we're missing an x term. So we're going to write 0x in for the x term. Then we find out, okay, a is 1, because there's a 1 in front of our x squared, b is 0, and c is negative 16. We want to find out what multiplies to give us a times c, which in our case is negative 16, but adds to give you b, which in our case is 0. So 1 and 16 are not going to give you 0. They'll either add or subtract to give you 15 or 17. 2 and 8 are not going to add or subtract to give you 0. They add to be 10, subtract to be 6. 4 and 4, however, there's a possibility. If one of these is negative, they'll multiply to give you negative 16, but they'll add to give you 0. So now that we know the two numbers, you can split the middle. X squared minus 4x plus 4x minus 16. Group them together. So in the first two terms, we have an x. Factor that out of both of those, and you have x minus 4. Here, we have a GCF of 4. So take the 4 out, factor it out, and we have an x minus 4 here. The big GCF we have between these two terms is an x minus 4. And then if you cross those out, left over is an x plus 4. And you've got it factored. So notice that there's two terms in these. We're going to talk a little bit more about it today and kind of notice what their answers are turning out to be. Okay, let's keep going. So let's do one more. X squared minus 1. Again, we don't have an x term, so we're going to use a 0x. And we want to find out what multiplies to give us a times c. Oh, wait, before then, let's write out what a, b, and c is. A is 1, b is 0, c is negative 1. We want to find out what multiplies to give us a times c, which is negative 1 in our case, and adds to give us b, which is 0. Well, 1 and 1 is our only option, and that's fine, because if we have one of them as a negative, then it'll multiply to give you negative 1 and add to give you 0. So we're going to take our middle, and we're going to split it. So x squared minus 1x plus 1x, using these two terms. Then bring that down, minus 1. Group these two terms here, we've got x, x minus 1. Group these two terms here, we've got a 1 only to take out, nothing changes, and an x minus 1's in the parentheses. The big, huge GCF between these two is x minus 1, so take those out, read it left to right, we got x plus 1. So let's take a moment right here, because it asks us what pattern do we see. So if we move up here, do you notice that in all three problems, we have two terms? More specifically, x squared, 9, 16, and 1 are all perfect squares. What is a perfect square? So let's take a side journey over here. 1, 4, 9, 16, 25, etc. those are all perfect squares because you can take the square root of them and get a nice, even, pretty, no decimal kind of answer. See that? These are perfect squares right here. So, and also notice in all three problems there's a negative sign. So, what pattern do we notice? All the terms are perfect squares. And then if you also look, in every single one of these there's a minus in the middle. So they're subtracting. Okay. So there's more to it than that. We've just described what kind of problem we have, but now let's kind of look at what kind of answer we get. So notice this was x plus 3, x minus 3, and it came from x squared minus 9. Notice this is x plus 4, x minus 4, and it came from x squared minus 16. And notice this is x plus 1, x minus 1, and it came from x squared minus 1. So one thing you should notice with all your answers here, there's a plus and a minus. So let's write this down. So it factored to two parentheses, one with a plus and one with a minus. And then look at the terms. So the square root of x squared is x. The square root of 9 is 3. The square root of x squared here is x. The square root of 16 is 4. The square root of x squared is x. The square root of 1 is 1. So what went into these parentheses, and those are the square roots. Of each term. This is called the difference of squares. So they're both squares and there's a minus sign. A minus means difference. So that's why it's called the difference of squares. So with that being said, we can go in and try to use this little shortcut in the next couple of problems. And I want to kind of show you what ends up happening here. So, and I tell students, if you don't see the shortcut or if the shortcut is difficult for you, don't use it. Don't use it. Do what I just did on the last three problems. I didn't use the shortcut whatsoever, and I was able to factor. So the method that we've already learned in class, you can continue to use that to factor. But I do want to point out, the pattern too. On the next couple, though, they could be tricky. So if you look at example 4, and we do this the long way, which I'll show you in a moment, it's not going to work. Notice that 11 is here. When we take the square root of 11, it's a decimal, so it's not a perfect square. So you can't use any kind of pattern here to factor the problem. If we look at this problem, a is 1. Again, my middle term 0 is missing. So if we look at this problem right here, and c is negative 11, if we find out what multiplies to give us a times c, which is negative 11, but adds to give us b, which is 0, I don't think there's any possibilities. Your only choice is 1 and 11. And there's no way you can get a 0 out of that. So this is just unfactorable. So whether you're using the shortcut or doing it the long way, you should notice that you can't factor this one. Example 5 looks really promising because it's x squared plus 9, and those are both perfect squares. So you think that you might be able to do this, but let's investigate a little bit because there's a little something different about it. So if we did this the long way, oops, I didn't mean to do that there. Let's do this. If we do this the long way, a is 1, b is 0, c is positive 9. And we can rewrite this just like that. What multiplies to give you a times c, which is 9 in our case, but adds to give you b, which in our case is 0. 1 and 9 won't work because they subtract to give you 8 and add to give you 10. And then the only other option is 3 and 3. Well, it's got to multiply to give you positive 9. So these would both have to be positive or both have to be negative. And in any case, if it was 3 plus 3, it'd be positive 6, not 0. And if it was negative 3 plus negative 3, it'd be negative 6, not 0. So there's like nothing that works. You may have been tempted to say that this answer was x plus 3, x minus 3, if you were to use this shortcut up here called the difference of squares. But watch out. We said that there needed to be a minus in the middle, and this one has a plus sign. So this one is also unfactorable. Let's look at example 6. One thing that we haven't talked about yet is what happens if there's a GCF in here. And definitely in this problem right here, there's a GCF you need to watch out for. In both of those terms, we can pull out an x, and we're left with an x minus 4. Here's a mistake that some students run into. They get really happy with the pattern and they think these are perfect squares. So this x minus 4 must be x plus 2x minus 2. But be careful. This is just an x. It's not an x squared, so it's not a perfect square. And literally the problem just factors to that. Some students will also pull out this x and they'll write unfactorable as their answer because it doesn't go any further. But when you pulled out the x, you factored, so it's not unfactorable. So keep that in mind. That's a common mistake I see. And like I said, if you just do the steps like I did the first 3 problems, and really how I did example 4 and example 5, you'll be fine. I just like to point out to everybody that there is a pattern. So let's talk about the pattern a little bit. I'm going to take a side journey. You don't have to write it down. So if we have x squared minus 16, that's a perfect square, that's a perfect square, there's a minus in the middle. So what you can do, take the square root of x squared and you get x, take the square root of 16, you get 4, and it's plus minus. That's what it factors to. If you have, let's switch it up a little bit. So what if we have 25x squared minus 9? This is a perfect square, this is a perfect square, and there's a minus in the middle. So if you take the square root of 25x squared, that's 5x and 5x. Take the square root of 9, that's 3 and 3. Plus, minus, or minus plus, doesn't matter. So that's how you would use the pattern if you wanted to. But I highly suggest doing it the long way and then going back and using the pattern later on once you're comfortable. All right, till next time. Bye!